Hello, I'm JW. Today we're going to have a look at these things which I took out of a phase converter the other day. These are capacitors. I put a short video of it on Twitter, and there's a question on Instagram about these and what happens to them when they get old. And the answer is that they lose capacitance. So if they had a certain value to start with, after a certain number of years that value will diminish, and then eventually they just become completely open circuit, so there's no capacitance there whatsoever, and of course they don't do the job they were intended to do. This style is either polypropylene or polyester film or something similar inside, and they're designed so that they don't actually fail short circuit, because if they did there could be a large explosion and flames or whatever coming out. So they basically fail open, and so eventually just end up with no capacitance left. So let's have a test of these and see what sort of values they've actually got compared to what they should have been in the first place. So here we have a selection of these capacitors. Now these came out of a phase converter. A phase converter is a device which allows you to run a three-phase piece of equipment, such as a motor, when you've only got a single-phase supply available. And they're the sort of thing you generally want to avoid if possible, because they're fairly expensive things to purchase. As we've seen here, the capacitors wear out after a certain amount of time and need to be replaced. And even when they're in use, they're not, of course, 100% efficient, so there's a certain amount of wastage and losses involved. All that generally is wasted as heat. And unfortunately in this case there was no alternative, because it's a three-phase lift that was installed in a building that only had one phase available. Although actually it was two phases available, but that's another story. So unfortunately this was the only choice. But anyway, we've got a load of these, and they've got a date on here which is presumably 906, which presumably is 2006, or maybe it's 2009. But anyway, they've been in service for in the region of 10 years, so certainly well exceeding the lifespan of these things. Now these are all supposed to be 64 microfarad, and they're all the same. And let's just see what some of the values are. Now, so these I've just removed. I had to cut them out of the equipment because, bizarrely, they were soldered in originally. Normally you just get the press-on connectors there, but they didn't use those. And if you're going to remove capacitors like this, when you actually remove them, it's a good idea just to twist the two leads together and then leave them in that shorted state, because it is possible for these things to be completely discharged, and then if you leave the leads open, then a charge can reappear in them and shock people at a later date. But these have been left shorted for several days now, so I've just undone the leads here, so have a quick test of them. Now just a question of attaching the two leads. This line in the middle, sort of embossed in the plastic, denotes the two sides. So you've got these two terminals are basically connected together, and then these two also connected together, though they've actually got a wire soldered on them as well. But that line is basically the two terminals. So let's attach this one to see what we have. Well, that's a big fail, isn't it? Because this is supposed to be 64 microfarads. Actual value is 1.2. So this is basically completely destroyed, fit for the bin. So let's try the next one. So let's attach to the wires there. Okay, well that's now rating 65, so that's perfectly fine, and this is actually in perfectly good condition. Well, maybe. So although they came out of the same machine, completely random, one's completely bust and the other one is seemingly reasonably okay. Try this one. Okay, well that's 55, so that's on the low side, because that's nearly 10 microfarads low. Although these are a 10% one, that's still well out of the tolerance, so again that's considerably lower than it should be. Moving on to the next one. 62 or almost 63, so again this one, that's fine. And this one, 8. Well again, 8 is clearly not 64, so again this one is totally destroyed. Let's try the next. 15. Well, once again, that's very far from 64. So let's move on to this one. Still got the wires twisted on that one, so I missed that one there. Attach those. 54, so that's 10 microfarads down. Again, that's still well without the tolerance, so they're nowhere near as bad as some of the others. And number 7, number 8 I think it is now. Yeah, 56, so again that's similar. Again, it's still lower than it should be. And then this one, 63.5. Well, that's close enough to 64, so again, that one is fine. And the last one, get it onto the wire there, we have got 52. So again, that's still far too low, but again, it's not quite as bad as the ones we had at the beginning. So look, there's some capacitors, all of these out the same piece of machinery, all been used for the same amount of time, and of course all the same age, being put in when it was made. As we saw there, some of these are measuring pretty much as expected, around the 64, but others, of course, pretty much all gone. And all of these have now been replaced, obviously, with new ones. As the main problem which was showing up was that the passenger lift, which is running off of this phase converter, was having various problems in that it couldn't actually operate correctly. And if you put too many people in it, all kinds of bad things happen. So it had been sort of down-rated to a smaller number of people, but of course if left eventually all of these will fail and then it won't work at all. So those have all been replaced. And so phase converters are not the sort of thing you normally want to use, because generally you have three-phase equipment, you want a three-phase supply. I think in this case what's happened is that the building was constructed, this lift was put in at the time, and of course they assumed that three-phase would be available, and then when the supply was actually fitted they discovered that three phases were not available, hence the phase converter was put in about that time. And this building actually has two of the three phases available, but of course that's still no good because you still need all three to run three-phase equipment. Now that's it for this video. Now I did actually take a short video of the actual lift and things in operation, and we can see the sort of current that this draws on the single phase side, so I'll just put that in at the end here, and until next time, thanks for watching.